Good evening, everyone. First of all, I want to gratitude for all the participants and also the one who created this seminar. And firstly, I want to also gratitude for my mentor, Professor Muhammad Anuraga Jayanegara, and Dr. Ani Pulpi, and myself. Hello, my name is Muhammad Ashan Jayanegara, and today's research is about protein content and sensory evaluation of meat analog made from fermented peanut. So the outline is the first is introduction, and the second is methods, and the third is result and discussions, and the fourth is conclusions. So first of all, let me introduce why I chose this title. Is because first is food and nutrition crisis conditions both at the national and global levels. So presently, over 1 billion individuals globally grapple with protein deficiency. Indonesia too faced this challenge with over half of its population, 53.4%, looking at that, meeting the recommended protein intake. Protein deficiency not only affect human health but also diminish overall intelligence and healthy quality, leading to long-term issues such as diabetes, coronary heart disease, and stroke till presently, potentially reducing global food availability by up to 3.2%. And then the third is prediction of the decline in food production due to global warming. Conversely, Indonesia boasts the second largest biodiversity globally and ranks the 10th in agriculture, one of which is variety of local tropical legumes. That's why this is a very good research for our country because it has so many effects on it. And the fifth is tropical legumes are resistant to extremely conditions, highly nutritious but contain high level of anti-nutritional compounds and low protein distribution. The sixth is Indonesia local wisdoms in the form of template fermentation technology, which is able to increase nutritional value and reduce anti-nutritional compounds in legumes. And then the last but not least, evaluation of the results of biodiversity explorations. The next is method analysis, which contain proximate analysis, calorie content calculation. So the result and discussion is the first one is template diversity. We have the 7 variants that we find out, and then the second is protein content by of the 7 variant tempes, and then the third acceptance role of development meat analog from soybean tempe and black oncom. So as we see in the next slide is there's some product of legumes that are that have a good content on it, and then the first one is being lam toro and landing tempe. Lam toro is not widely used in Indonesia. Lam toro is easy to grow in tropical climates. Landing tempe has a unique taste similar to a combination of soy tempe and sticky rice. The drawback of this tempe is not, it is more difficult preparation method. This is because lam toro beans have fat from their skins. Soaking the beans takes quite a long time. Landing tempe contains 35% protein by dry weight. And then the second one, we have a velvet bean and bengok tempe. Velvet bean is a legume of the same family as peas and beans. It is gray to black in color, although velvet beans contain cyanide acid. Soaking them in clean water for 1 until 2 days will remove the poison, making them safe for consumption. After fermentation, these beans become bengok tempe. This tempe contains relatively high protein, around 31.2%. The third is we have peanut and black oncom. This can be utilized in various dishes such as satay seasoning, dumpling seasoning, fried peanut snack crackers, and more. And then the fourth, we have a winged ban and vegetable tempeh. This is climbing vegetable. It is usually used as a complementary vegetable in soups or sour soups. Processing winged beans seeds into tempeh is similar to soy tempeh. And then the five, we have agati seeds and agati tempeh. Agati seeds have a similar color and size to soybeans. Agronomically, agati plants have advantage. One plant for a lifetime, bear fruit all year. Productivity can be increased with pruning, adaptive and dry land, minimal maintenance, and softer seed husk. And the sixth, we have the next one is the sixth, we have mung bean and mung bean tempeh. Not only soybeans, but mung beans can also be processed using Rhizopus sp with protein content of 41.92%. The last but not least is red bean and red bean tempeh. This contains up to 33.85% protein. The next one. The next one is about protein content of selected indigenous tempeh from Indonesia. So we know that additive protein source for global warming currently, the need for protein is urgent. This is evident from the large number of global and national population that lack protein. The protein deficiency indicates that the current global protein sufficiency is still insufficient. Insufficient. Prediction of the increasing world population indicate that the production of the protein food sources needs to be increased immediately. Furthermore, with the prediction of the declining ability of the earth to produce agricultural yields, the needs to search for alternative protein source becomes even more pressing. Additionally, the expanding production of the biofuel crops that produce renewable energy due to the limited availability of fossil fuels make the production of the protein food crops increasingly competitive with the need for energy. We can look at the table one. uh, we can look at the table one. There's a protein compounds ranging from 31 until 41%, which is pretty high in tropical regions. And then the next one, this is a table sensory evaluation results of black oncom and soy kebabs. Respondents, we actually have 20 respondents from our residents, and then pretty much they are all liking the kebab with soy. The average scores of 4.75 and 4.5 respectively, it can be tested respectively.